Okay, interesting I-num char. Uh-oh. My voice went on a squeal there. And yeah, I'm so funny. And string I-num num num num. So there it is, folks. Basic, basic, basic. The next two questions are not so easy. Now, if you were counting a space, you'd put a space there. If you're counting vowels, you put a set of vowels there, A, E, I, O, U.
We don't want to do uppercase and then small a, then we do that as well.
Well, you should actually do uppercase, because otherwise you can't be matching properly.
Well, if you count for I-num chart, small a.
Only if you're going to lowercase, so use a lowercase function to make sure everything is lowercase.
Well, no, because then it will count the capitals and the small letters.
Yeah, well, this is why we keep it uppercase, because this keeps everything the same.
Okay.
But you might have one capital, one small. You don't know what the person's going to type in.
Yeah, but it could count both. It increases I-num chart.
Oh, you can put like this. You can do a small a to...
Yeah.
Yeah, but I mean, what's the point? It's much...
Or you could write another line. It's like a...
Yeah, no, but that's a bit messy. You don't need to.
Okay.
This is a neater way, quicker way to do it.
Maybe
Yeah, it's quicker.
like for the...
It doesn't worry the noughts and the nines. That uppercase is not going to interfere with any other characters. So you don't have to worry about that. Okay, moving on. Let's go this one now. Okay, number 2. Now it says here that you have to use a repeat loop, but no. We're going to use a while loop. So I'm going to cross out that repeat, and I'm putting in while loop here, guys. Don't say I didn't tell you. I'm going to use a while loop here. When a car is bought, it will depreciate in value. The percentage of depreciation is 20% every year. So we're going to put in the initial price and calculate and display the yearly value after depreciation until the value is less than or equal to half of the initial price. You must use a while loop. So change that to while loop. Complete the code in the calculate button in the question 2 tab sheet. So let's go and use a while loop with this one. That means our condition is going to be at the top. So double click the button, let's get our initial value. R, start, real. What about our end value that we want to achieve? We know we're going to go down and down and down until we get to end big less than or equal to half of our start. Now what about our depreciation? Let's make it our dep. So I have these real numbers, and I'm going to make sure I know what they are. So our start is going to be, now nothing in this question said that we have to check to see if it's a real number, so you don't. Only if you asked to check something, then you check it. But if you're not being asked, if there's no instruction saying, make sure that the input is a real number. No, there's nothing there saying that, okay? So you don't have to go and check to make sure it's a real number. So you don't have to do val. You can go straight off and go and get the number from the edit box saying string to float. Remember, string to float. EDT price dot text. And our end, the end value is going to be, did they say, less than or equal to half of so we'll say R start divided by 2, and then we're going to say while R start is greater than R end, do begin and end. As soon as it's less than or equal to R end, this loop will stop. So there's the trick there. And we're not using a repeat loop, we're using a while loop, people. While R start is greater than R end, we are going to calculate what R dep is. So it's going to be R start times by what? 20 divided by 100. And then we're going to decrease R start by that value minus R dep, and then we will display everything. But we also have to have a counter. We also have to have a counter here. Hey. And why do we want to have the counter? Because we want to count how many years. So I'm just calling it IYS. Always, 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 we have to initialize our counter. And only inside the loop where we want it to be added to, we'll increment the counter inside the loop. Now we could be adding interest, or in this case we are subtracting interest. Take note how we want to stop when R start is equal to or less than R end. So in the while loop we'll say while R start is greater than R end. R end being half the value of the initial number. What are we going to do here as well? They say write code to receive it and display the yearly value. So every single year we must display. So that's what we're going to do. We're going to display the yearly value. And yeah, why not? We're also going to display how many years it'll take, you know. Yeah, why not? Well, there it says year 7, not so. Anyway, we want to count, we have to display the year as well. So I had an increment years there. Then I'm going to say red out dot lines dot add. So now it's a big long string we have to put here into string. Years. That counter. Maybe put the word year in front of it. Plus. Let me get this back so you can see it. And then we're going to join that to #9. #9, people. Forget about your #9s. You're in big, big trouble. The next thing we have to do is the value, R start. Can you see R start is going to go down? The value is, and join that to #9. And then join that to float to string f. R start ff currency and comma 8, comma 2 Okay, so that should work. I mean, we could go and display our years, but, you know, is it necessary? Okay, fine. Already out. Advanced.add. Oh wait, no, we're not going to do that. Okay, can I run this program now? I'm running it. I'm running it. I'm running it. Hey, did I do this one? I'm just going to put a lot of things here. Check. Anyway, calculate price. So we start at 35,000. Year 1 the value is that. Year 2 the value is that. So it goes down. And year 4 we got like see, because 18,124 is still not half of 35,400, you know. As soon as it hits below half the value, then we get that year 4. There was a bit of a trick one. So we use loops for this obviously, but a while loop is quite a good one to use for this. But you could also use a repeat loop if you used a repeat loop in this one, then it also would be okay. Except in the question, if it asks for a while loop, then you do a while loop. Okay, we can go and do this one. Right, you must complete the code in that one, do the following. 2 random numbers must be generated and then see if they are both equal to 6. It says here use a while loop. No, we're going to use a repeat loop to count how many times the numbers must be generated until they are both equal to 6. So we'll display the number every time and and that's what we're going to do. So it looks like this, and how many tries it took to get a double 6. So you must use a repeat loop. It says, I'm writing here repeat. And the reason why you must use a repeat loop is because when you throw dice, you are going to throw it once, aren't you? So a repeat loop is used when you know something's going to happen at least once. So we throw it once and we don't get a 6, fine. If we throw it once and we do get a 6, that's also good. That's why a repeat loop must be thrown. That's why it must be a repeat loop, not a while loop. But it's easy to adapt it. You just change the condition. Yes?
So the memo that we have on the page we got, we mustn't use that. Is that using the while?
Yeah, it's got a while loop, not a repeat loop. But I mean, it's nearly the same. It's just you use it just back to front. That's all. You'll see. It's about the same thing. You need to understand the mechanisms behind it. With the repeat loop, you just use this different, you just use, your condition is the opposite to what you would use in a while loop. So if you check that out, you'll see. But let's not worry about that now. Let's go and do the job. And let's focus. When we roll dice, we're going to roll the dice. So we're going to get 2 random numbers, okay? And we're going to say repeat until these 2 random numbers are both equal to 6. So there's my structure. Even if I roll it just once, if you pay attention to what I'm doing, then you'll be fine. If you're not going to listen, then you're not going to be fine. It's really quite simple. If you're going to do your own thing, then you will get it wrong, obviously. So, I've put in my skeleton there. So that sort of makes sense. I'm going to repeat this until I-num 1 equals 6 and I-num 2 equals 6. We can throw dice for many reasons. We can throw dice until the 2 dice are equal to each other, whether it's a 6 or not. We can throw a dice until we get dice that are not equal to each other, or that are both equal to 0, or until I-num 1 is I-num 2. So we basically can do that. But how do we throw dice in programming language? We use random range. So this is what we're going to do. You need to actually pay attention and not fiddle around there. Are you ready? We'll say num1 colon equals random range, open brackets. What are the numbers for the dice? 1, 2, 6. So you say 1, 7. Random range 1, 7 if you want numbers from 1 to 6. num2, random range 1, 7 will give me a number from 1 to 6. Okay. Question is, what do we do now? We have to have a counter, don't we? We want to have a counter. Well, I must remember, what is this processor doing? It's going to start getting a random number, 2 random numbers, okay? Then we can do something else here. There's a super cool space here, we can do anything. You know, we can put code here for the processor to do stuff if we wanted to. But knowing that all of these instructions here are going to happen before the processor hits onto until. The processor first looks there, num1, then there, num2, and then whatever's there, and only then does it go and check, is num1 equal to num2? Is num1 equal to 6 and num2 equal to 6? But I'm going to do an if statement here, if num1 equals 6 and, no, I'm not going to do that, sorry. I'm just going to increment the counter. My bad. Why am I going to increment the counter? Yep. Yep. If it's 1 and we get it, that's fine. If our count is only 1 and then we see, oh, num1, they both the dice rolled both to a 6, then we're fine. Okay, no problem. But then we have to roll it again if it's not. Our count must be an integer. Also, our count must be set to 0 before we do anything. We can do other stuff over here before the processor gets to checking. If num1 and num2 are both equal to 6, we can do something else. The question is, what is that we need to do? Well, if we look at our output, I'm not even reading my instruction properly, but if I look over here, I can see we've got to display every single throw of the dice. Dice 1 and dice 2 in neat columns, and we use #9s to separate the columns. So, and then afterwards we're going to display our counter. So we must display in the rich header. Let's go to our rich header. There it is, red display. We're inside the loop. Red display dot lines dot add. And if you looked at the code for the while loop, you see that the inside bit is the same. Sweetheart, you'll see that the inside bit is the same if you look at the code for the while loop. So, already displayed lines.add. What are we going to put in here? Well, we're going to put in the word dice 1 and sort of like something to show what we're talking about. Then we're going to put in the enter string num1. Let me join that to the #9. Don't forget about the #9, because then we have going to dice 2. I'm copying and pasting because I'm super lazy. Yeah. Dice 2. Enter string num2. This is happening inside our loop. Every single time we throw the dice, we increment the counter and we display the dice numbers. And remember, throwing the dice is using random range. 2 integers, colon equals random range 1 to 7. Any number from 1 to 6 will result, will be produced by the super duper processor. And now the cool thing is, we then go and display after the loop. We can make a space. There's a space. And then we can display our count. Into string our count. I also want to put a nice message there. Number of throws to get a double 6 in this case. Maybe you want to count how many throws to get the 2 dice equal to each other. It doesn't matter whether it's a 6 or not. Now you can imagine that to get double 6s is going to take a lot of throws compared to getting double anything, eh? So you go and put this code in and run your program, and I think we're done. While I'm running my program, am I going too fast? It says 14. Whew, 3 throws. And then we have 14, not number of throws. Anyway, that's it, folks. Oops.